Hello there, everybody, and welcome to Sky Tour live stream. It's a wonderful night out there tonight. We're looking forward to it. And before we go any further, I just want to bring in Daryl. Hey there, Daryl. How you doing?
Well, Mark, I'm well, thanks. You?
I'm fine, thank you. Things are going okay.
Hi, everybody.
So I think that
sunny day here today.
Was it really?
Oh yeah.
Wow. Okay. Just want to ask a question. Is my sound okay to you guys? Do you hear my sound just fine, or does it sound like it's overmodulated? Just let me know what you get there. All right.
You sound different to me. I wouldn't know how to put my finger on it.
Different? In what way?
Overmodulated? I don't know.
Okay.
Maybe a little tinny.
All right. Okay, it says too loud. Yeah, you know what? That's interesting. Okay. How about this? Is this better? Tell me if this is better. I bet you this is going to be perfect. I bet you this is going to be just perfect now. Yeah, okay. I had a volume level thing, and I managed to get it back to where it should be, and I think Daryl is where he should be as well. All right, very good. We have a moon that's just past first quarter right now, and thank you for your help on that, guys. And so we're actually checking out a few objects that are near kind of near the moon, but not really. They're, we have a ways to go. It's not quite dark out there yet. But we'll be able to check things out, I'm sure. I'm going to try a few things. I'm going to try setting up just have a 1 second exposure out there to see if that actually can work right now or not. Yeah, well, we got a satellite there. That's interesting. There we go. And it went through already, though. There it goes. Ding, ding, ding. Here we are. We could just sit here all night long and just watch one spot in the sky and look at. We see Starlinks going through. And we'll see satellites galore tonight. Especially now, because I'm in an area that's within 20 degrees of the celestial equator, so you can see a lot of satellites out there. Okay, so now what I'm doing is I'm going to this is where our position is. It's sort of a nonsense position. We're not in any place that's really of any consequence, but I'm going to bring us back to this globular cluster right here, because that's kind of fun, and we're going to do that. All right.
A lot of globulars
you can see
in that field.
Yeah, look at them all. I mean, I think we should spend some time poking around at these globulars and see what we get. Now we're gonna pull this globular in. Let's do this. Let's show the field. Okay, now in our field here, we should see this globular at the lower right. Let's see if it's there. There it is. I think that's it right there. And to know for sure, even though it's not fully dark yet, we'll take a, I'd say a 12-second exposure. Get rid of our night vision view. And we're going to have that satellite in there too, by the way. Alright, here we go. And we'll live stack this.
You do sound kind of hot. Pardon me.
Well,
sort of buzzy.
Well, everybody is saying that it's good now.
Go for it.
But I'll let them correct me. I mean, if I actually bring it down a little more, well, then it will put me here, and that's, see, JSCO says it's good. All right, no big deal. Okay, so here is that little tiny globular. Look at that. That's beautiful. Let's zoom in on it. We're stacking it anyway. I have not done a focus run yet, and we will because I want to do that. Yeah. Actually, it's pretty interesting. Not bad. But we'll do a focus run. So we'll get rid of this. Let's go maximize and go to 1 second exposure again. Now we're in night vision mode. Now click that, bring that up. All right. And now we'll drop it down to our auto frame. Actually, I can do 20%. And actually the best view, I think, is going to be, I think, at 40. That's approximately correct for the size of our field. Yeah, see, 40, 35. Okay, so 35 is good. All right, and do we have 35 in our list? Yeah, we do. Okay, so good. 35% is what auto size would bring us to. I want to say hi to everybody. Hi there, JSCO and Anahata. That's Bonnie from Colorado, near you, Daryl. Not near, but close. Vera Lucia Campos has been with us earliest. He was here first. And then NPC, hi there. How you doing? Tim F. Hello, Tim F. And we have Taryn Marie. We have Fantasy is with us. Cosmic Ray. Robin Curtis. And we have Prow. What's going on, Prow? Good to see you, man. Donald Kunzer is with us. Good to see you, Donald. It's nice to have you with us. Bullwinkle, what's up, brother? Good to see you, man. And I want to just say that I am happy to be with you tonight. Mary Kazaninski is here. That's Kaczynski, I think. Yes, it's a little round fuzzy. That's right. And I believe that is all of the people that I said hi to JSCO. Yes, I think it's all the people, so we're cool right now. Good. All right. Okay, good. Yes, Heavens Above is great, Cosmic Ray. Thank you for putting that link in there. We often use Heavens Above to figure out where things are in the sky relative to us right away. And our telescope also has the capability of looking at the star patterns like it sees right here in the screen and figuring out exactly where it is in the sky. Hi Daisy and Zoe, good to see you as well. Okay, so now we're gonna do our focus run here, and I'll go to the focusing assistant here, and we're gonna do multi-star, full width, half maximum. You see all those squares, those are the stars. And I'm now gonna connect our focuser with this right here. We're gonna connect that up and put it into the train, and we're gonna defocus the telescope. All right, and by defocusing the telescope just enough, you see how the stars become little donuts. Actually, when it's in this mode, we can actually see the color of the stars better. And that's one of the things we actually use to check out the color of the stars, is a defocusing method. All right, so we focused outwards, and now we're gonna scan in and go past that focus, that perfect focus, and go back to out of focus and make a curve, which will appear right here. You'll see a curve appear here. All right. So that's doing it now. All right.
Uh-oh, chewing ice on the air.
Well, I heard you make some sound just a moment ago too.
Yeah.
I'm actually.
Hard time.
That's right. This is a grape juice with ice in it. I did not mean to chew the ice. I hate doing that. Okay, we're at 8 of 12, and then we're gonna go to each focus run. We go to a specific spot, and then the stars are sampled, and they get 3 samples each star, Okay, and look, our point of best focus is determined already. And once we have the green bar, we can then say best focus, and you'll see this line go all the way across and all the way back. And then we come back, and when it comes back, boom, we're now at perfect focus. You can see the stars are absolutely perfectly focused. So now we can get rid of our focus, and now we can take another exposure just to confirm we're looking good. We're going to do a 15-second exposure. Why not? Okay. And we'll take off our night vision mode and go back into the stack and clear what we have and see what we get now. I suspect it should be much better. Oh, that's much better. Now the stars are really focused well. There we go. And we'll zoom in now in the globular cluster, and let's see if we can resolve it to the stars. Okay, we're at 129% on our sensor already. This is a small globular cluster. If it was larger, that would mean it would show the stars better. Hey there, M. Turner. How you doing? Oh. And we've stacked 3 here. Let's see if we can process this a little bit. Yeah. You see the noise. It's this fuzzy nature here. When we have moonlight out, we're going to see more. We're going to see more of that. So what I can do is I tone it down like by doing this. Okay. And I also want to enhance the picture just a little bit. We're going to do an unsharp mask, and it'll sharpen it up a little bit, and you'll see. Okay, so now the stars are actually much sharper. Look at that. All right. Really nice. Yeah. Nice. Let me turn off the bilateral filter. I just turned it on to check out how that would look. That's cool. All right. Okay. And as Daryl mentioned, there are a lot of these in this region. Here's a little planetary, but that's probably very small. Let's see how large it is. Oh, it's very tiny. That's so tiny it would look like a tiny star.
Got M19 down there toward the bottom left.
I see it, yeah. Why don't we go there?
Sure.
Okay. So we're going to go to M19, but before we do that, of course, we're going to kill this stack. We're not saving these until we get something good. All right. And I will go and do a quick pick of our 1 second here. Go into night vision mode, and then we will tell it to go from here. All right, here we are. Now you'll see it go, and now what I'll do is, okay, we're gonna bring up this. You'll see the stars streaking. Okay, as it does this, then we can come back down to 35% or so. Okay. And now we're putting that star in the center. That's Theta Ophiuchi, and this is about the center right here. You can see that that's pretty good. Minor adjustments, it's doing it, and then we're gonna go whoop off to this globular cluster measure 19, which is right here.
That one's big and bright.
It's much brighter, isn't it, Daryl?
Well, that's why it's a Messier object, I guess.
NPC says, when is the next live stream? I'd like to have a schedule. actually, NPC, that's the problem with astronomy. We depend on clear skies. So we can't actually predict the next one. We've been averaging every other day, actually. And now that we're out of the monsoon season in Arizona, we're going to have clear nights almost every night, if not every night. And then we will actually be able to stream pretty religiously like every other night.
Yeah.
Okay.
The moon can be a factor too, as we, especially get closer to full. Though it wouldn't be the first time we ever streamed near a full moon, I have to say.
No, we have streamed and saw some pretty remarkable details and things.
Oh yeah.
Yep. Okay, so this is Messier 19. It's a globular cluster, which is in Sagittarius. And I'll just prepare that for you so you can see it. And we're gonna let this thing come in. We've got 2 frames stacked, so we can, when you get 2 frames stacked, that makes sense to do processing on it at that point. So we can actually do a little processing now. All right, and do a color balance. Okay. Look at all the stars. I mean, it is just astonishing to see all these stars. Okay, in fact, when you see it like this, one of the things we have to do is actually pull back on our intensity that we've managed to attain to actually allow you to see it better. And that's what we did. See, so now we can resolve this. We see all the stars. And if I take it back a little more, we can see even better. So there is a globular cluster. These are called halo objects. I've talked about this before. They orbit the galaxy, and they're made of the oldest stars, among the oldest stars in the universe. And that's what halo objects are in these galaxies. They're actually among the oldest stars in the entire universe. It's pretty cool. So this Messier 19 Globular Cluster.
And they all have their own character. This one you see, there's a sort of a line of stars across the bottom, just left of the bottom. And then there's a dark line above that, and actually 2 dark lines. That's really interesting.
Right there.
Yeah.
Right there.
Kind of jagged looking, got a big tooth sticking up in it.
Right there. Right there. Look at that thing. See, it's like a jack-o'-lantern. Look, there's an eye. There's an eye. It's a wacky frog. Cool.
Interesting.
It is. Looks really pretty.
I'm gonna have to look that one up.
All right. Let's see here.
It's in Ophiuchus, actually.
Oh, it's right above Sagittarius then.
This one that was actually discovered by Charles Messier himself. Blah blah. William Herschel resolved it into individual stars. That's also not unusual.
Mm-hmm.
His son John Herschel described it as a superb cluster resolvable into countless stars.
And that it is.
M19 is one of the most oblate of the known globular clusters. Blah blah.
Oblate in that it's not perfectly spherical. It's actually got more of an oblong look to it. Now that could be, I mean, as mentioned, these are halo objects. They'll go plunging through the disk of the galaxy, and then come up through the disk of the galaxy on the other side sometimes. And if they do that, well, then you'll notice that these objects are also going to trail some stars behind, maybe pick some up on the way through. That's been my understanding of them anyway.
Says the emitted light is being strongly absorbed along the eastern edge, result of extinction caused by intervening gas and dust.
That's this side.
When viewed in the infrared, the cluster shows almost no flattening. I assume the gas and dust may be what those dark bands are across the lower left.
Well, I think that the general dimness here is what they're saying, that this side of the cluster is being absorbed. The sunlight's being absorbed. You can see these stars are reddened a little bit.
It's about 28,700 light years away.
That's a pretty good distance.
Quite near the galactic center at only about 6,500 light years.
Yeah. Hello there, Moshe Orlano Tronkowsko. Nice to see you. Thank you for coming out. Subscribe if you haven't. And join the fun. We look at all these objects live. The universe is live, and so are we. Okay, we've stacked 16 of these. That's pretty good. So we'll actually save this. This will be Measure 16, M16,
19.
GC. I'm sorry, 19, thank you. It's not the Eagle Nebula, no. 19 GC. Okay, there we go.
It's very red, too.
Yeah, I'm wondering whether that's a issue with the color balance, because if I align the curves, this is what it looked like. So that might be red due to the moonlight, and I can walk that red curve back a little bit, like that. All right, and get it to here, and then you got to drop the green a little bit on the dark side. See, to try and get it back to what it should be. That's I think what it probably is more like.
It's very interesting, globular.
It is really
and,
pretty.
The wiki article has a pro photograph of it, and it shows those same dark features and light features along the bottom left, the bands and the jaggedness in them and all that.
Mm-hmm. That's cool. Okay, we got 21 done here, stacked. So we've made a image sandwich of 21 images here. So we're going to pause it here, save it, and then save it exactly as seen, just like you see it here. So you can explore those dark bands and dark lanes in this globular cluster for yourself as well. Okay. And next, we're going to go to another object nearby to kind of show you what we were talking about when we were saying that each globular has its own relative signature, if you will. Let's see. We have... I bet you we could do M22. It'll be bright because it's near the moon. You know?
Yeah. There's M28, and there's M22.
Yeah, we'll do... We're going to try... Oops, that's the wrong thing.
That's the tadpole. You know, there's
Right,
great
I want this
Sagittarius.
one. Yeah. So we want this cluster. So that's where we're going to go in just a second. So now we'll go into our night vision mode and go back to our 1 second exposure here. This is just so you can see things the way that you would see them live. Okay, so you can actually watch things move. So like if I move the telescope, you'll see that it doesn't move. Right now it's actually moving quite fast there, and I just changed it back to slower. But now we'll go back to to here, and now we're going to go to the Great Sagittarius Cluster, which is very close to the moon, so that'll be kind of interesting to see how this looks. Here we go. Off we go, and we can pull away this guy. We don't need that. So here we go, we're off on our way. The sky's going to get very bright as we move closer to the moon at the moment. And it's a cluster right there. Caus Borealis. And there's Measure 22. Yep. Now, here is another globular cluster. You just saw one that was very small, and the second one that was kind of small. Well, now here is a bigger one. Or, shall we say, a closer one, perhaps.
I know they say if it was farther north, it would rival M13.
Yeah. Let's center it up. That's perfect, almost. Okay. Now we'll just go a touch to the west. Okay. And now what we'll do is we're going to take another exposure of this, but we're gonna do this. We're gonna take we'll do 15 seconds. That might be too much at this point for this, but we'll find out. It might work out okay. So now we get rid of our night vision and come in here and clear this previous one. But there's a good view of it, so now you saw how big it is. All right, and now you watch how big Measure 22 is. There you go. That is a really stunning globular cluster. Look at that.
Sort of dark bar across the right side of it.
Right here, yeah. Let's zoom in on that. So there's a dark thing across here. And you see there's some... Now, we're looking at happenstance, right? Because these are clusters of stars. So it's actually, you know, not uncommon that these clusters might have some kind of artifact for where... from the particular position we're viewing them from. And that's what we see here. We're seeing that right here. Hey, PG, how are you? There we are. Okay, let's change our view here a little bit. There we go. Okay, get a little more going in there, and I'm going to soften this up a little bit. Oh, now that's beautiful. Look at that.
It is.
And we can darken it just a little bit more. There we go. Keep in mind, the Milky Way is right nearby. Wow. Look at that beautiful globular cluster. Measure 22. Let's see. Bring that down a little bit. Okay. Alrighty. And we'll call this M22, which is also a GC. Okay.
Very nice.
It is pretty.
I noticed when we were moving toward M22, M28 is just over on the other side of Caus Borealis. Perhaps we could check it out too.
Okay. All right.
Look, it's almost got like an upside down chevron shape over just
right there.
Right of the top.
That you're talking about, right? Right here?
Yes.
Interesting, because I noticed that just as you said that.
Yeah, it looks kind of like a letter A.
Yeah, upside down. Very cool.
That's really
And
nice.
we're at 111% on our sensor, and this is so this right here is the native sensor size for us. That's pretty. Now, I'll tell you something about these stars, and as I mentioned, they're some of the oldest, and they're actually stars that have very few elements other than hydrogen and helium in them. So when I say they're oldest, that kind of makes sense, because the older populations of stars formed in the universe, known as population 2, are stars that have not had time to be formed with the foundational products created by supernovae in stars, which are, all the other elements in the periodic table. So they were formed in the pristine universe when mostly there was hydrogen around and not a whole lot of helium, some lithium, okay? But when they were formed just from hydrogen gas that then fused into helium ash in their cores. And thus, these stars, as plentiful as they are, the cluster like this might have 40,000, 50,000 stars in it overall. But as plentiful as these clusters are, these are not clusters that would probably have life in them or planets. And that's because of the fact that they were formed without the planet making stuff, which means that they probably didn't have nebulas around them full of other planet making material like silicates and magnesium and iron atoms. So most of that stuff was not there. So they're probably very pristine. But if we find planets in these globular clusters, that's probably because the globular cluster went down through the disk and dragged along another star that was different. And I think that would separate. And that's actually a study I'd like to do. That's a study I'd like to do. To see if those stars are in fact, being dragged up.
Could you say that again?
I'd like to do a study to show if the stars are being dragged along or left behind by globular clusters when they go through and plunge through the galactic disk in some cases.
Oh, okay.
Yeah. Because that way, if we see that there's a star that's in the globular cluster that has planets, we know that star is probably not native to the cluster.
No.
Okay, we got 26 stacked here. We're going to pause this here. And we have Measure 22, GC, Globular Cluster up there. So now what we can do is we can save this. This will save to our online database. There we go. And it will save it exactly as seen, just like you see it here. So you can go have fun and look at it. And if you want to know where you can go, well, go there. Go to skytourlive.com. And skytourlive.com, scroll down to the next section under the main arrival spot, and you click on the button and it takes you right to the database, and you click through you scroll down till you get to today's date in the directory, and then you keep going in until you see processed. There's a processed directory, and in there you will see these photos, everything we take. All right. Okay, so there we go. That's beautiful. Now we're going to go back to 1 second and go into our night vision mode, which is pretty in itself. All right. And let's zoom back out. There we go. Okay. Daryl said he wanted to see measure 19 now.
No,
I'm sorry,
28.
measure 28.
Right there.
That's right here. So what we're going to do is just change the speed just slightly and then head on over that way. And that's going to take us a little bit westward. So we're going to click the W button to go west. There goes measure 22. Okay. And here we go. Now we have to go south. As we drop south, we're going to just manually drive to it because it's right here. And there it is. Boom. Notice the difference between the previous and this. All right. Now let's just, this is the live view, so let's scroll in on this a little bit and see it live. You see all the stars, the image doesn't change, but the noise in between does. That's what stacking does for us. It eliminates that noise and the image looks much nicer. NPC says much smaller. Yeah, it is, as you say, so much smaller. Okay,
Smaller
we're guiding
than what?
again. Measure 22.
It's actually because it's
Visually.
farther away.
Well, visually in the sky, it's smaller, yeah.
Oh, well, yeah. It actually has over 500,000 solar masses. And satellite. They found a millisecond pulsar inside M28 and have since detected a lot more inside it.
Interesting.
Uh,
A millisecond pulsar implies that there was a supernova, guys, and that means the star in this globular cluster exploded.
A total of 11 further millisecond pulsars have since been detected in the cluster with telescope at Green Bank Observatory.
Okay. We're going to do a 20-second exposure of this. Get out of night vision mode and go into our stack. Okay, there's measure 20, remember. Okay. That's why I'm leaving it, so you can see it. Okay, so then we come out and we'll clear that. We saved it. It'll be up on the server momentarily.
Oh.
And there is measure 28. Let's
I'll
just
post
stick
a
on
link to the server in a second.
Okay. Thank you. Let's do a color correction here. You know, you're seeing all these stars are all in the foreground. Okay, they're all up here in the foreground, and that cluster is way, way out here in the background. Okay, so we're seeing it through all these stars. Very, very nice. So, one thing I wanted to mention was that I wanted to welcome you to this wonderful Labor Day stream. You know, because that's something we haven't done. Is I don't think a Labor Day stream before. This is beautiful. And we can still do nebulae too, and we'll do some nebulae as well. I mean, while we're in the neighborhood, I should show you a few. And then we'll make our way up over the top.
Stay away,
Should-
clouds.
Yeah, we should be good. Okay. Oh, wait a minute. This is what I want. Okay. All right. Okay. We've stacked 7 of these because we did 20 seconds. We'll let it go to 8. And then we'll save it. And this one is Measure 28, M28. Again, a GC for Globular Cluster. And in case you think I forgot, there you go.
This area is so rich in globular clusters. Forget who it was, Harlow Shapley or Vesto Slifer, someone like that. He did a statistical analysis of locations of globular clusters in the sky, and found that Sagittarius is where the most are, of course, and that was one determination that of the direction of the center of the galaxy, just off the tip of the teapot in Sagittarius. I have to look that up. I forget who did that. Astronomers have such interesting names. Vesto Slifer, Harlow Shapley.
Well, that's just... I think that's just the names of the time, you know?
Oh, absolutely, sure.
All right, so...
Can we zoom in on that?
Oh, well, I'm about to head off of it. Yeah, the sky's a little unsteady tonight out there. I'm not sure what the deal is, but, you know, we'll make do. You know what I'm talking about?
Poor saying, you mean?
Yeah. Not sure why, but...
Oh, well, God, you were...
I mean...
It was like 110 out there today, wasn't it? And now it's cooling off into the 80s?
Yeah.
That could be doing it.
Yeah, we're getting some probably the heat rising off the desert, you know. And if you notice where we're looking kind of toward, you know, the south, and that's a problem as well. Okay. All right, so now what we'll do is we'll come in here. See, there's the moon. Should we look at the moon while we're here?
Sure.
The telescope is not a moony type telescope, but okay, why not? We'll just check it out. Watch out for your eyes. I'm actually gonna knock this brightness way down and bring the exposure way down. There we go. Alright, and we'll make this about 70 milliseconds. And then go further down to 10 milliseconds. And then move up from there. Oh, well, no wonder. I have to bring the gain down. Alright, there we go. So, here's the moon tonight. Okay, we'll do 7 milliseconds. There we go. So there we go. Let's actually, just to give you an idea of the size of our field, it's a good thing to do. If we fill our field with our moon, if you measure this and you measure, you'll see it's 1, 2, 3, 4 full moons across, and 1, 2, 3 full moons tall. Okay, so that's the size. So it's about 2 degrees plus a little bit, and 1.5 degrees plus a little bit. So that's the size of our field. It's a wide field telescope, so that's why looking at planets, for instance, is not the best thing with this telescope, because they're tiny on the screen, because we're looking at a large swath of sky, you know. So that's why if you talk about doing lunar streams, if we get a bigger telescope, a better type of telescope for looking at planets and things, then that's something that I think would be appropriate to look at. But until we do, then we can't do that with the same type of precision that P&K space imaging can with Paul and Keith. So, all right. As I watch the moon, I'm always waiting for like a Starlink satellite to go across in front of it or something. Because that happens. I've seen that happen like dozens of times.
I went out about 3:30 one morning.
Yeah.
There was an ISS pass. This is back in the days of the shuttle. And the shuttle had just disconnected from the ISS. And so they were very close in the sky. I went out to look at it, and what I was prepared for was they flew right in front of the moon.
Oh.
Because I wasn't prepared for it. Well, you know, no camera or anything, but I got to see it naked eye, and it was over in less than a second, but it looked really cool.
Yeah, it goes so fast across the face of the moon that it's actually way less than a second that it takes to go over that whole space, because it's 252 miles up in our orbit. The moon is a half a degree in size, and the ISS is moving over 17,500 miles an hour.
Yep.
So it just goes zip, and it's over that quickly. So it's like a third of a second or so that it might take to cross the moon.
Can you zoom in a little?
Yeah, I can. Let's see how we got that.
I see Tycho. I see Clavius.
Right there. There's Tycho right there.
Clavius right below it.
Right here.
A little farther down.
To the left. Down there.
To the left.
Oh, right here. Duh.
Yeah.
Has a deep shadow. Deep shadow on the wall. Yeah. We could try. Let's see. Well, this is pretty good, actually. There's Copernicus crater. There's Plato. Just for your view, Plato was 60 miles across. That's 60 miles right there. Yep. Not bad. I mean, like I said, this telescope is tuned more for doing star field photography and nebulae photography. But
yeah,
we could blow it out a little higher here. Bring that gain up. Doesn't take much. All right. We'll do a snapshot. Okay, so we have a snapshot of the moon now in the moon. We don't stack the moon because the stacking software dynamically doesn't. I don't have it working too well with the moon. It works for everything else but the moon. But that's okay. That's what we do. All right. Now it's on to a nebula to test our system here. We'll just do this right here. I'm going to go to we're going to do the Lagoon Nebula real quick just to see how well the lagoon shows up when the bright moon is right nearby. So here we go. Let's do a 30 millisecond shot here. So just under a third of a second. Alright. And this is the star it wants to center. Yeah, pretty bright with that moon. Okay. And there we go. Alright, I think we probably... That's where it says it is. But I don't think that's where it is. Alright, well, I'm just going to do a 10-second shot here to see. But I don't think that the telescope is... Oh, it looks like it says it found it, but I don't see the cluster. Alright, well, let's find out. Let's find out. Alright, we'll take this off. We'll go into live stack mode. And clear out our last Measure 28 shot. We did.
Somebody pointed out your gain is quite low.
Oh yes, that's true.
I guess
I actually
have it down for the moon. I guess you had it turned down for the moon.
Yeah. Well, that's a good point though. I want to show while we have it down low. Okay, you can see this area in the lagoon very nicely right here. Now you see that hourglass looking shape right there? That hourglass is powered by an O-type star, the hottest and bluest stars in the universe, right? And so I don't know if the star is hidden from view or it's this star. I'm not sure. But that hourglass is just one one piece of evidence that the nebula is being caused to glow by this O star. This entire region is being illuminated and forced to glow by one bright O-type star. Not only that, there's a stellar nursery here that this has become, and these stars were formed here, and their powerful stellar winds are also, no doubt, ionizing some of the hydrogen gas around here. But that's a beautiful image, and sometimes doing this like this will show some details that you may not expect. And this shows some details in here. And I'm going to use this actually to do what's called a center brightening reduction process, where the next photo you see, you're going to see a bright nebulosity, and this entire region is going to be blown out white and bright. But I can actually use the two to make a balanced image where you can see all the stuff in the center and all the stuff on the outside. Kind of like your eye would see it with the big enough telescope. So this is the Lagoon, and it's called we're going to make this a lower short exposure Lagoon Nebula. Short exposure. Okay. Just put that out there for you to see. All right. And we'll do 18 stack images. That gets us to clarity. There we go. Now we'll pause it and change this over here to Measure 8 Lagoon, and it's an emission nebula, EN. Okay, and now we'll save it. Okay, and now it's saved, and we'll save exactly as seen. And we've done that. Okay, now we're going to clear this stack, and we're going to come back and make this a 35-second exposure. And before I do that, I gotta raise my gain, so I'm gonna raise it up now. We're gonna go to 250 with the gain or so. So that should be good, around 244. All right, and we'll see how it overlays this. So watch it overlay, and then we'll have to probably reprocess. And okay, oh, that's the last buffer. I'm sorry. You couldn't see it because the last buffer was overriding it. My mistake. Hey, Jessica S. How are you? Good to see you. Let's pull that out. We don't need that right now. But now you'll see how it looks when you have this brightness. Yeah, see? Kind of bright. But let's actually process it so you can see it. Okay. Now you can see the brightness I was talking about. And let's go in and let's first of all color correct it. And when you color correct, you see you get all the other colors. Now, that's beautiful, okay? But we're missing the whole center of the nebula over here, which I showed you just a few minutes ago. So we take those two photos, that lower exposure I showed you, and now this one, and we actually put them together. And you'll see this. Hey, Pam Strutman, how are you? You'll actually see the center of the nebula while also seeing all this detail on the outside. And why don't we actually just soften it and deepen the blacks in the background. In other words, compensate for the moonlight. Look at that. Ah, that's just beautiful. Beautiful, beautiful. Okay, now we can put our ID back there. And let's actually pull it over and make it a bigger screen so you can see everything here. Look at that. Really cool. Hey, Papa Tom. Papa Tom's in the house.
Can you zoom in for a second on that little thing down at lower left? We looked at that recently, didn't we?
This guy down here, the cluster?
Yeah.
Yeah, we did. It's right there. Hi, little guy. Yeah. Was it a globular cluster? I'm not sure if that's a globular or... well, we can just go in here and
I
see.
don't remember. What does...
Well, it's easy to find out. Yeah, it's a starfish cluster.
Oh, no, okay, that's right.
Yeah, and that's a globular cluster. NGC 6544. Okay.
You gonna do
Alright.
the dragon?
No, I'm not going to do the Chinese dragon tonight because I wanted to do some other things, and I just wanted to point out to people how the exposure can show you how you can make you miss some things. And then what we'll do is I'll create the image. So you saw the really dim one and now the bright one, and then you'll see what happens when I put those together and make them balance better. Good evening, Uberku. How are you? Chantel is here. Hi, Chantel. How are you? Good to see you. Oh, yeah. Okay, so this is actually... What?
I'm sorry. You're going to blend low gain or short exposures and higher gain, longer exposures of the lagoon?
Yep, to show this section of the lagoon at the same time as showing all this stuff out here. It'll be a nice, it'll be a blended image that'll show it to you like your eye would see it. Your eye doesn't see, your eye doesn't see things overexposed.
Yes.
You know, did you ever notice that? Your eye doesn't see overexposed. Yeah.
Is that something new for you?
It's a new process.
We talked about this before.
Yeah, it's a new process that I've developed in Photoshop that I did the processing in.
Oh.
I can't do it. I can't do it live. You know, without taking it down that whole rabbit hole of processing. I mean, maybe someday, actually, if you want to see a live Photoshop processing session, I'd be happy to do it. You know, so you can watch what I do and how I bring things out. But here you see what they look like. This is not what they look like when I get the raw imagery off the server. You're seeing something that's been processed for you. You're not seeing the raw imagery. The raw imagery doesn't look like this at all. It actually looks just like stars with faint hints of nebulous detail, and that's about it. You know? By the way, I don't know if you can see my shirt. It says, "Aliens don't believe in you either." Just thought that'd be kind of funny to wear. Very nice, Justin T. Thank you for coming along for a little while. Prowl says, Mark, did you ever figure out what those diagonal line artifacts are from? Yeah, these diagonal line artifacts, which only really show up when the moon is out, shows me that there's some type of artifact that's on the sensor or possibly on one of the lenses deep inside the telescope. I'm going out, what's today, September? I'm going out in November for a week into the desert to work on finally getting rid of this, but I need another person to manage all the glass we got to be moving around. It's heavy stuff, and I'm not gonna sit there and try and balance all this stuff in my hands. I'm gonna need someone else, so I've got someone coming out with me to help me. Hello, Corey Williams. Corey Williams says, everyone says that the actual images do not have color. That saddens me. Actually, Corey, don't be sad because that's untrue. Okay, the actual images are color. It's just that your eyes can't see the color when you're looking through an eyepiece. That's the confusion I think you have there. When you look through an eyepiece, you see mostly black and white, but the color will show up on exposures where you can accumulate light on a sensor. Our eyes can't accumulate light. It's instantaneous and it's gone. And we don't have giant eyes. If we did, we might be able to see that. So in a big telescope, you can see hints of color sometimes. A very big telescope. Were you going to say something, Daryl?
I was going to dispute what you just said. As you said, I mean, it depends on the size of the telescope, but bright objects, you can see color. I see color.
Not in a nebula.
Green is most obvious. I have seen hints of red in the Orion Nebula.
But only with a big telescope.
10-inch telescope, no bigger than yours. It was a refractor, not a compound telescope, but I can see hints of red and see plenty of green through the telescope.
Okay. But notice you're saying hints of red. Okay. You don't see color like this with your eye through an eyepiece ever, unless you've got some type of massive telescope that you can use that'll do all the light collection for you instead of your eyes.
I would agree with that. I mean, it's subtle, but it's there. It's not
that's
all
the
just
problem.
Black and white.
No, and
I
that's
see
the thing.
green in planetary nebulas too. Some bright planetaries.
Yeah, I have looked for a long time at nebulae with a telescope, and I know that with a 10-inch telescope, looking at the dumbbell, it still just looks like a white smudge. It does not look like we see it with the camera. It just doesn't.
And for all that, though, I like to say sometimes it can be like looking at a picture of a sunset versus looking at the sunset. It's just not the same.
What's that mean?
I think that's pretty obvious what it means.
Means you'd rather see it through an eyepiece?
I'm sorry?
Means you'd rather see it through an eyepiece?
Yes. Things at their best. Showcase objects, at least. When I saw M51 through a 41-inch telescope, and I'm sure an image through a 41-inch telescope would have looked impressive as hell, but M51 Whirlpool through a 41-inch telescope, I don't think an image would have stood up to what I saw by my eye. That's a darn big telescope, though.
Yeah, it is. Well, I, having used darn big telescopes in observatories for years and in the past as I was doing all my work, I know that what I saw with my eyes never rivaled what I got on imagery. You can't see this and study it and look at it, and say, wow, and you could never see this in an eyepiece in all this detail. It depends on the telescope, and if you have access to one of the world's biggest telescopes, you can see this, but you can't see it. You can't see it generally. So I think that imagery always is better than seeing it by eye. I don't agree with that, but that's just me.
I guess I'm just old-fashioned.
No, there's a.
I mean,
a wonder
you said
to that.
yourself a minute ago that the eye has a dynamic range that imagers just cannot match. That you could
correct.
look at the lagoon, and you can simultaneously see the hourglass and all the
That's
faint
right.
details around it.
That's right, and that's the one. That's what I mentioned is one of the things we have going for us, because you could see this, or you can see that, all with your eye. Okay. Now the sensor we're using has a very high dynamic range as well. It sees things kind of like the eye, but it accumulates light, so that overall our image can look like this. Okay. Or this. Let me just get it right. All right. So that's what our image can look like overall. But we have that dynamic range like the eye, but you can't see it all at once. You have to, they're discrete layers, effectively, that the sensor creates that we can go through and pick out. It's actually very, very small layers, infinitesimally small, and we can slide all the way through all the levels of brightness to get to the very, very center of this and utilize that. So I think that's kind of the best. To me, that's the best approach, is to try and get get all the detail we can. And one thing you can't do with your eye is do what I'm doing right now. We can't get this contrast. We can't play with the imaging dynamically. So I think that's pretty cool. But this is stunning. All right, and this is good. We're gonna stop here. This is our longer exposure lagoon. We're gonna pause it, and I'm leaving this indicator up here. It's gonna go in the same directory. Okay, and we will save it, and then save it exactly as seen. All right. So we have a fairly bright moon out there, and as you can see, we still have a pretty nice image, don't we? That's pretty nice. Hey, weird guy's here. Yeah, you know, weird guy's correct. I think he knows where you're heading with that. I mean, I started my astronomy career just by looking through eyepieces. You know, that's all I did. And the thing is, I never knew what the exposure was going to create. I never knew what I was going to get. So, for instance, I looked at M82, which was the starburst galaxy that's pumping copious amounts of energy out at north and south poles, and also has this really, really disheveled look. And I was guiding an exposure of this galaxy for an hour and 45 minutes. The weather was about 10 degrees inside the dome, and I just sat there on the ladder and I guided for an hour and 45 minutes. It was so cold I didn't even feel the telescope hitting the ladder and crumpling it around my body. That was a problem. You know, you've heard me tell that story before, I think, Daryl.
Oh yeah, a couple of times.
Yeah, that was kind of scary, because I got sort of trapped in there and I had to figure out how to get out in the dark. You can't just turn on the lights, because you got to reach for the light switch, and I couldn't reach the light switch. I was trapped up there with the hand controller, and it wrapped around the ladder, wrapped around me. But it took such a subtle amount of time that I didn't notice it. You know, I didn't notice it. That's kind of weird and maybe sort of absent-minded, but it's true.
Well, if you were focused on the crosshairs, I suppose, of your guiding.
I was. That's all I was looking at. Thank you for giving me the excuse. Okay. Let's go up now to the north. And let's first... Okay, let's do this. Alright, so first of all, here's what I'm watching. Let's just pull this over. Okay, this is our observatory right here. This is Arizona. These are the clouds that are moving down. It's moving through Arizona, but it's taking a significant amount of time, I think we'll be fine.
Mm-hmm.
A beautiful night. Okay, there we go. So let's get back to our main view here.
And they were actually getting some rain up in southwest Colorado. They need it as usual.
Yeah.
Clear as a bell
Okay.
on my side of the state.
Yeah. So let's push this out of the way. Let me see the telescope again. Okay, now let's go into our night vision mode. Pop that up. Oh, hello, Lagoon. Really pretty. All right, and let's go up into Cygnus, the swan. I'm thinking we'll start up here with this beautiful nebula. See how it looks with the moon. This is we're looking at a supernova remnant right now that's going to show up here.
There was an interesting story making the rounds a few days ago about a guy who won blue ribbon at the Colorado State Fair in an art exhibit. And it was an AI created work using a AI program, I guess, called Mid-Journey, which has been making a lot of splashes lately. I see it often online. He basically came up with a description that he fed to the program, and the program created the supposed artwork, in quotes, unquote.
Wow.
And he won first place. And some people had a real problem with that, you know, he didn't create it, the computer did. That's sort of a philosophical thing, and Bonnie just commented on that.
Yeah, I guess that's true.
It's funny. I talked to Izabela about that, and I sent her one of the articles about it. Showed the artwork. It's a really cool piece of work, and she thought it was great.
Mm-hmm.
She had no problem with it. And I suppose, you know, in her point of view as well, programs like Mid-Journey can give people who aren't great at painting or drawing, perhaps, can still give them the creative tool to put what they think up, if not on paper, then on a computer screen. Now, this guy, he had
allows
taken
them to express their creativity. Yeah.
Yes, and she thought it was great. This guy,
Izabela's an artist.
Yes. This guy who created, or who had the AI create the thing for him, he had it printed on canvas and submitted that to the state fair. And it was a neat looking image.
What was it?
It's hard to explain. I'd have to go pull it up. I could show it to you if you want to see it. It's neither here nor there, though. No. It looked like they were at a temple or something, looking through a big portal.
Okay. All right. Well, that is an argument for another time, isn't it? Because that's really kind of strange. What people would actually consider valid art. So, okay, this faint little guy you're seeing here, you can actually see some faint color. You see some green, and there's a little red here. Now, we'll see that better. Now, this is what it may look like in a big telescope, minus the green cast to the background here. Okay, We can actually monkey with that, but I don't want to. But this is a faint supernova remnant. It's the one side of it, okay? The side toward the west. This star is called 52 Cygni, and that's actually a foreground star. This remnant here is about 2,400 light years away. But this whole area, this is known as the Witch's Broom, and we're going to take an image of this right now. So we'll do this for 35 seconds, and you're going to see some gorgeous wispy structure in this supernova remnant. All right, and then we'll live stack it, and we'll get rid of the previous one. Look at that. That's the gorgeous Lagoon Nebula. And it's up on the server by now. All right, so this is going to be a 35-second shot of that wispy western veil. And what do we get? Before we process it, now let's process it. Oh, yes. And let's color correct it. Even better. And look at the other stuff that shows up. Look at that. Isn't that beautiful? You can see all kinds of additional detail in here, especially over here. That's the central veil. This is the western veil. And all the way on the other side, we'll check out the eastern veil. Hey there, Edward. How are you? Nice to see you. Mayan Taurus, what's going on? The pictures of constellations on stars is a form of art. Yes, it is. Indeed, it is. Actually, there were artists in the 1800s were competing voraciously to be the ones whose artwork ended up in books in astronomy. Wayne Torres says, one of the great thinkers of all time concluded, I know nothing. What will AI conclude? He may just agree with you.
And Skynet smiles.
Yeah, right? I always said Google is the next Skynet. Google is the manifestation of the movie. Wow. And Boston Dynamics is the facilitator to bring them the robots to do it. Look at this beautiful nebula. Let's zoom in a little bit on this. Look at that. There's your twisted tornado there, Daryl.
Yep.
All the way down to here. Speaking of tornadoes, we had one here today. It came raging through west of here by about 20 miles. Never made it here. But as we speak, there are storms out there now. I can hear the rain. Marianne Robb says, that is so beautiful. I already have the Eastern Veil on my wall. Framed canvas, waiting for my Western Veil print, which should come in next week. And what you do is, these are on our at skytourlive.com. You can go down past the first section, which brings you to the database, to the Get Photographic Print section, and you can get like this particular thing on separate panels and put them up as separate panels of canvas, which show the Eastern and Western Veil together. We're going to do another set where we're going to actually do an equal exposure of the Central Veil, the Eastern Veil, and the Western Veil. And then you'll actually be able to get all three and put them up as a nice 3-panel artwork on the screen or on your wall. This is part of the central veil here.
Whoop. Oh, you're putting that up.
No, I'm not.
Oh, okay. I see
But
it
now I
on
will.
I see it on my screen.
Yeah. Yeah. That's the shared screen, but I wasn't sure. This is what Daryl said. This is the AI generated artwork. I'd have to look at what is actually going on there. I mean, I do this kind of stuff. I mean, I render photorealistic stuff, and I don't know that I have a problem with what I just saw, because the AI, maybe it did part of it, but I don't think the AI generated the people and then shaded the people, put their clothes on, and did all that. I think the artist does that.
No, it's a program called Midjourney, Midjourney, and as they say in the article, they call it a text, or somebody said it's like a text to imaging. He writes a description, and the computer creates the art.
Oh, okay. That's interesting. I'll have to check it out.
Oh, yeah, when you have time.
Well, all I can tell you is we're not using Midjourney for this, guys. Chantel, thank you for coming, and I hope you have a really good evening. And it was good to see you here for a little while. So, good night, Chantel. Cosmic Ray, always doing these wonderful things for us, telling us about the objects we're looking at. I really enjoy that. Thank you very much. He says 52 Cygni, 291 light years. That's 89 parsecs away. And the Veil Nebula is 2,400 light years away. Very good. Yep. So as we said, the 52 Cygni is only a few hundred light years, 300 light years away, and the Veil is farther behind it by a long shot. Very nice. Well, let's see if we can do a little processing to bring out any more detail now that we've stacked as many as we have here, which that number is 12. So okay, let's increase our contrast by bringing our black level up a little. Oh my. It is so full of stars. This halo is an artifact of the system. I get rid of those in post-processing, actually. Look at that. Should we zoom in? Let's start at the top. Remember, we got a bright moon out there, too. Okay, we're at 121%. Look at these beautiful filaments here. And Daryl mentioned to us in the past how the thinnest of these filaments is about the size of the distance from the sun to Pluto. And this is probably a very thick filament compared to that. I mean, it's probably even thinner than this. Look at that. Let me drop the noise level a little bit. Wow. Beautiful.
What always gets me is how the different elements manage to keep separate I mean, and sometimes they don't. I guess they mix sometimes, but the pure green, that's all oxygen, and the pure red, that's all hydrogen, and
Right.
sometimes they, how did all that happen? And how did they not
Well,
just get mixed up like oatmeal? You know?
well, the thing about light is different from paint. That's how I look at this. And I tell people that too. When light emits a certain wavelength, and you have another wavelength of light being emitted near it, you get what happens is you get the additive result of light being added, which is not the same as paint. So it's different. So if you have like a reflection nebula, which is deep blue, and I'm talking to everybody, not just you, because you know this, Daryl. And you have a nebula that's inside the reflection nebula, and it's emitting in the red. Well, the red light and the blue light will add up to magenta light, and you'll actually see that red nebula inside the blue nebula glowing magenta, not red. In this case, what we have is these distinct tendrils, these distinct gas clouds. How are they so distinct? And that's kind of where Daryl's going with this. Why is this section red? And why is this section green when they look like they're part of the same strand? Well, part of the reason for that probably has to do with the dominance and density, dominance of a particular frequency, and the density of the gas in that region. So I don't know the answer to this offhand, but the density in this region is actually quite sparse, right? This is called a rarefied gas. There's very few atoms per cubic centimeter in this region, maybe between 10 and 10,000 or so atoms in a cubic centimeter, when you expect 10 to the 19 atoms per cubic centimeter in, say, regular air, okay? But the density being different is probably why we're getting a peek through, say, of red here versus green. I'm not sure what the density is throughout the Veil Nebula. You can certainly find generic numbers, but you can't, unless you actually reference papers that were done on it, you're not going to know the density of this particular strand, because this strand has been named. These strands have all been named and categorized in papers, but this is, to me, one of the most interesting regions right here. It goes from green to bright red to green. Now, it could be that this red is in front of the green, and so the red might be dominating because of its density, and the green might have been lower density back there, so it doesn't come out as bright. I think that's all possible.
Well, I called it oatmeal at first. I mentioned over in the chat, and you talking about, mixing light versus mixing paint. Imagine you had a couple of pitchers of different flavored Kool-Aid, and you poured the grape Kool-Aid into the cherry Kool-Aid, and either you didn't stir it or you stirred it just a tiny bit, enough to get it moving. That, maybe some places the cherry and the grape would mix together, and some places they'd stay separate. Some places in that, I mean, you see those little skinny green filaments when we were farther down in the witch's tail here, the witch's broom. Such a vivid, pure green. I would think that would have to represent pure oxygen. Oxygen only, not hydrogen.
Yeah, doubly ionized oxygen for sure. But keep in mind, what's interesting is it has to do with the dominant reaction anyway, because you're getting more than one oxygen transition to create this glow. Okay? When the oxygen atom is doubly ionized, those electrons, when they come back in, they may not fall to all to the same level every time. They certainly don't. But the dominant one, the predominant one, that is the one that is seen most often, is the one that gives this green light.
Yeah.
Okay, same thing with hydrogen, right? Remember, we have multiple series of lines in hydrogen, right? We have the H alpha line, we have H beta, we have H gamma. Okay, that's the Balmer series. We also have the Lyman series, which is LYMAN, the Lyman series of lines in hydrogen. Well, where are those? I mean, the thing is, the dominant one in nebulae in these particular cases are the red transition, which is the drop to that second level in the hydrogen atom. It's called the N equals 2 level. And that's the predominant one. So density, the predominance of a reaction, those all relate to what color you're going to see and how much of it. You know,
So
if it's very thin, it just might be washed out.
so not Kool-Aid even, more like Jello. Lime and Jello?
I
Or
guess that's that's cute. That's actually really cool.
Mark, excuse me a moment, please. I'll be right back.
Okay. We're going to keep letting this develop for us here. Okay. I want to try and show you something. And where is it? We're fine because we're still building this image up. We're up to 27 stack. This will be a really pretty image. In spite of the moon too, which I think is pretty cool. Wow, look at that. Oh. That bottom is really cool. It's called a witch's broom, obviously, because it kind of looks like one, you know. And this isn't even the most exciting part of the veil. I'm going to show that to you here in just a few seconds. Well, a few minutes. But I wanted to show, sorry, that was a wrong thing to hit. Okay. Okay. I'm sorry, I just can't stop looking at this. It's just so beautiful. Oh, it really is. All right. This is the Veil West, and it's a SNR, supernova remnant. All right, and we are at 29 and now 30 stacked, and we're going to stop it there. We're going to pause it, save it. Okay, and this again is our Veil supernova remnant, the western segment. And after we saved it as our astronomical fits file, we're then going to save it exactly as seen here. That's gorgeous. That is just so gorgeous. Wow. Oh. Unbelievable. Wow. The majesty is just stunning. We'll see the whole thing. Look at that. Look at these beautiful subtle colors in here for the central veil. Wow. Okay. Well, we're going to go off now and find the other half. All right. To find the other half, we don't have to go far because it's right near here. And it's going to be right there. Let's do this. Okay. And we're now going to go to the eastern veil. And we're in our 1 second. And we can take this out there. Come here, you. We don't need you there. All right. Now let's go and move east a little bit. And we're heading to this little guy right there. I guess I could go a little faster, huh? Here we go. Hey, James Dugan, how you doing? Yeah, right now we have this starting to show up here. That is our next target, and you're gonna love this one if you like the other one. This one's even more exciting. And we're gonna move it over. Center it up. That's about good. Go a little north. All right. And we're going to do the same length exposure on this one. This is the other half of that. Yeah, things are going great, James. Thank you so much. All right. Man, this is just really pretty.
Now, who does that look like? It's not really
Alfred
Alfred
Hitchcock.
Hitchcock. The nose is the wrong
looks like
shape. He's got a pointy nose and he's kind of a smirk on his face.
Yeah, okay. Well, maybe so. Maybe so. Okay, let's do a 35-second exposure here. I'm waiting until we get our, you see that it says searching. As soon as we get our guide stars, you'll see zeros appear, and then you'll see it starting to do the guiding. And that's what we're waiting for. Really do want to, oh, it's guiding now, okay. Takes about 12 or 13 seconds to capture that. All right, 35 seconds. Here we go. Now compare this guy. All right, let's compare this one to this next one you're about to see. All right, we're going to clear this now. Hey there, Jay Rich. Wow, look at that. Now there's the other side. Isn't that crazy? Beautiful. And there's a lot of detail in here too.
Oh yeah. Again, you
This
can
is
see
called
some places where The red and the green intermix in some places, like down on his chin, it's pure green.
Yeah. I'll take the object out of there for now. Well, keep in mind, it's also, you're seeing this in 3D. So they're overlapping each other all throughout space and intermingling. And they might be separate tendrils of oxygen atoms and separate tendrils of hydrogen atoms, but from a long distance away, they look like they're intermingling, and it's hard to tell how that's possible. But again, it's in 3D, so you have to keep that in mind too. Let's see if we can do something to help this detail pop a little bit. There we go. And then we're going to soften this a tiny bit. There we go. Let me see if I can move this back a little. Alright, so now we'll zoom in, Daryl, and we'll check it out.
Okay.
Look at that. We've stacked 4. Look at that tiny little arch right there. These tiny little thread. That might be like a distance of the Sun to Pluto distance right there. Look at this. Hard to believe this all comes from a star. But you got to keep in mind that as much mass as the star has, what you're looking at is extremely low density. It's not a lot of stuff. It's just spread out very far, and it's ionized. This is moving over 600,000 kilometers an hour as it moves out. And as it collides with other stuff in the interstellar medium, it creates shock waves, and those shock waves bounce back and forth, and they hyperheat this material until it glows like this. This is how this nebula glows. Now, as far as what caused it, somewhere between the eastern and western veil, two halves of this expanding shell of material, is a central area. That central area is where they found what's known as Cygnus X5. It's actually a soft X-ray source, and it's a source of what seems to be the remnant of the star that is left over after it went supernova. Usually when stars go supernova, they leave behind neutron stars, right? Neutron stars have closely packed surfaces. They're as hard as a billiard ball, okay? And they are extremely hot. They're packed so tightly, their surface is made of neutrons that are actually a hard shell packed together. And there's no more fusion reactions. It's just the stellar core that it's been shock compressed into this tiny little thing that's the size of a city. And that's the size of a neutron star. Yet some of them we can see from thousands of light years away because they're so hot, so energetic. So it's pretty cool. Robin asks, are we able to measure the densities of the various strands of gas or the pockets? Yes, that's done as well. Through observational measurements of the gas, they can actually tell the density in this region. Hey there, Genghis Khan. What's going on? Nice to see you. Please do hit the thumbs up. We could use all that. I'm not a very good marketing guy when it comes to this stuff, so you get the word out. Help me get the word out. Oh, man, this is just stunning.
I wonder... I know I've seen 3D modeling of some bright celestial objects like the Orion Nebula. I wonder if
Huh?
anybody's ever tried to 3D model the veil. When we see the shock fronts like that, folks, and the filaments, we're seeing them pretty much edge on.
Yeah, that's right.
So if we could take that face and rotate it 90 degrees to his left or to our right, I mean, surely it wouldn't look like a face anymore. It'd be spooky if it did.
Well, yeah, and so when you look at this, it could, we see it like this. See my hand? But from the side, it might be like this, right? Okay, but from the edge, it looks like that. You know, it has that edge to it. We see it like that. But again, it's 3D, and it might even be different. It might be more like this with much more material that is just further into the page, so to speak, and slowly curving around, which is why it might have that thickness to it, because it might be a curved net of strands that we're seeing.
Yeah. It would be neat to see a 3D model of it.
I don't think anyone has ever done one.
I sent you an image recently, I think, that actually showed Cygnus X1. Did you see that?
No.
I thought I sent that. I don't remember where I saw it now. If I can find it, I'll share that with you. It was like the neighborhood of Cygnus X1, and Cygnus X1 was down in it. You could actually see like nebulosity on one side of it or something.
Yeah. Wow. Marianne, I thought you were packing it in for the evening, and now you're still here in the chat. What are you doing? Go to bed already. You said you were going to bed. I'm kidding, of course. Marianne Robb is actually essential to Skyter Livestream. She's one of the people involved in the Skyter Livestream organization, and has done an awful lot of work out in the desert on the building when I couldn't be there, along with Tara Diulis. So we joke, but she's extremely important to all of this. Everything you see on this screen, all this,
Here it is.
she's responsible for it. In a long way, there's a long list, you know.
Do you remember me sending you an image of the Tulip Nebula in Cygnus?
No, I don't. We should look for it.
I'll send you a link. It was an APOD some days ago, and Cygnus X1 is over at the side of the image.
Okay.
All right.
How
sent.
big is the Tulip Nebula?
Let me go back and see. How big? It's 70 light years across. Probably doesn't answer your question. It's about 8,000 light years away.
Wow. What's its size in arc minutes?
Doesn't say yet. I'd have to go somewhere else to look.
Okay. Is it something that we can go look at?
Yes, give me just a moment.
Okay. I think that would be a wonderful object to check out tonight.
Are you looking at that image?
I did.
Oh.
I looked at it already.
And Cygnus X1 is over in that little blue area on the lower right.
Okay.
Also known as Sharpless 2-101.
Ah, there we go. That's what I wanted to hear. Okay. So, what I'm going to do is come over in here and bring up our data. And I'm going to include the Sharpless catalog, as well as Caldwell and Barnard. Those are the dark objects.
It's 16 by 9 arc minutes.
16 by 9 arc minutes. Okay.
16 by 9.
Okay. So this is Sharpless 2. I don't know how to... What's the other... Does it have another designation?
Sharpless 101 SH2-101.
Yeah, there it is. Where is it? Not far away. Alright. Good, because we're like a little over here. No, we're over here right now. So we'll find our way over there. Alright, well, let's first come back here now. And we'll come back to that, and then we'll check it out.
Okay.
Alright. This is going to be the Veil West. I'm sorry, Veil East. SNR, Supernova Remnant. Okay, this works. Okay, this is 25 stacked here. This is beautiful, guys. What do you think, huh? Look at that. This is the whole thing. And we come back to about the full sensor size right here. This is about the full sensor size, maybe a little smaller. Like that. Look at that. And then over on that side, we can see some of the central veil. Not bad for a nearly gibbous moon. Alright. So what we're going to do now is we're going to pause it. And we're going to save it. And we're going to save it exactly as seen because it's stunning the way it is. Alright. And now, let's go to this Tulip Nebula and see how it looks. Gosh, that's beautiful. Didn't mean that.
Looks almost like an X-ray to me.
What?
The eastern veil you just left.
Oh, looks like an
Uh,
X-ray.
yeah, that
That's kind of
profile
cool.
looks almost like a sight-on X-ray
Yeah, I guess so.
of the guy's head.
Yeah. All right. Let's go back here. And be here. And now we're going to say, go check it out. Off we go. So we're going to go from here to there. Uh-oh. That was a cloud. Did you see that?
Eh.
It was a random little cloud that just happened to come through. Alright, well, there'll be a few of those.
I see one over on the right.
Mm-hmm. I was showing Daryl the weather screen that I showed you, you guys earlier. This must be solder. Looks like solder. And it's going to center it up. And then it's going to take us from that Gamma Cygni, which is solder, to the Tulip Nebula, which is right there. Okay, let me just do one thing here. Alright. Alright. Now, let's see how it looks. This red, oh, here it is right there. There's the Tulip Nebula. Okay. Let's move a little bit to the east. Oh, we got a cloud. I'm glad I didn't start it. Well, you guys can watch clouds, see how they move across. Those obviously are going to be short-term clouds. At least I hope they are.
Jeez.
I know, right?
Sure is moving fast.
Okay, I think that we're good. Let's bring it over a little bit. I think this is gonna be kind of pretty. Oh, come on. They're not really moving fast. It's just that, you know, it's a fast-moving bunch of clouds. See, they'll ruin the exposure when they come through here. Let me see something here. Do this again.
Yeah, I'm looking on windy. The only one I see is that little one over on the right.
Yeah, but I'm pretty sure that what we're looking at on windy is not giving the granulation, the granular view of the smaller clouds. Okay, let's see here. All right. We're going to take a risk that the clouds have passed. When you can see a little bit of nebula, it means that there's a lot in here, and I think there's going to be nebula throughout here. Let's find out, shall we? I've never taken a picture of this. This will be a first. We'll do 35 seconds. And off we go. We'll come out of our beautiful night vision mode. Take one last look at this gorgeous, stunning God, Eastern Veil. It's beautiful. And it's up there on the database now with the others. So we can do this now. Let's find out if Daryl's Tulip Nebula is a good thing. Oh my, yes it is. Look at that, Daryl. Wait till this comes in. Okay, just calculating something here. Okay, let's go in here. Color correct. Okay. And let's bring this down just a bit and pull this back just a bit. This is our dark level. So brighten the background just enough to be able to start to see the differentiation between the black clouds. This is all dark nebula in here. This is a emission nebula called a diffuse nebula. This is a knot of gas, hydrogen gas, that is a stellar nursery. So we'll call that a real strong H alpha region.
If you care to take a look at that APOD image I sent you,
Yes.
note the bright stars in the nebula.
Yeah.
The orientation, those same bright stars over on the left side, they're like three in a triangle, and then another one to the upper left.
Okay.
Over there on the far left side. You have the very same orientation in your image.
Yeah. Okay.
Of the tulip.
Right here.
Those stars right there.
Yep. Okay, I see it. So.
And then Cygnus X1 is just off.
Over here?
To the lower left, a little closer.
You mean lower right?
Lower right, I'm sorry.
Yeah. I can see a wisp. I think I see that wisp. That faint wisp that's supposed to be there. There's a faint wisp there. Let me see it again. See this faint wisp?
Yeah, that's the shock front.
Yeah, right. And that's... I want to see if we can see that.
Yeah.
I bet we can. Unless this is it. Looks seems to be too far.
Yeah. If you see those two stars real close together to the lower right of the tulip.
These guys?
No, farther up.
These guys?
Farther up to the left. Two real close stars right there. Right. Whoop, you went right past them. Right there. Two stars close together.
Yep.
That appears to be the two stars in the lower right of the apod image.
Let's find out.
And
We'll find out.
one is red, one is white.
We're going to show you what we're talking about here. This is the object we're taking a picture of. You're talking about these two.
Yes.
Okay.
I wonder if that might not be them. Now, one thing I didn't know, I read elsewhere that Cygnus X1 actually has a companion star. It's a very hot O star.
Okay.
Of course, I suppose we might not see Cygnus X1 at all, since it's a black hole.
I'm pretty certain we won't.
Okay, and the orientation of those two stars is different. But there's the Tulip for you. That's pretty.
Yeah, I want to capture more. We've only done 9 frames. And let's see if I can do some kind of processing to... Okay, this looks like... Oh, I know what that is. Okay, that's that stupid diagonal artifact. Yeah, I don't think these are the two stars.
No. Orientation is different.
Yeah.
Well, we can see roughly where Cygnus X1 is at any rate. It's there to the lower right of the red.
Yeah, it's like in here somewhere. We'll find it. We'll find it. Let me do this first. Let me try to see what else is in here.
Izabela's here. Hi, Izabela.
Hello, Izabela. I'm glad you're here. Okay, now...
Those stars and the red nebulosity correspond quite well to the apod.
Mm-hmm. Alright, well, let's see now.
And the dark nebulosity inside it too.
Yeah, that's really pretty.
You already zoomed in a fair bit on this.
I'm at
As I said, I mean, it's only
72%.
Yeah, it's only 16 by 9 arc minutes, so it's not very big.
But our system has the ability to zoom in enough to see details.
Uh-huh. Izabela, this is the Tulip Nebula in Cygnus.
And Cygnus X1 is right about here.
Yeah.
And I wanna at least see some of the faint details that show it. Not you don't see the black hole, but I mean to see the shock front that's around it.
Right. Which I have never seen any of Cygnus X1 before.
Well, I think we'll be able to see something. Okay, I got the artifacts here, which I gotta get rid of. Alright, this shows me what's there. And I can see that what's there is not any of that faint structure. But we are only at 244 gain. Okay, we've stacked 16 here. And let's see if we can darken some things up here. Also, brighten up, darken up.
A lot of dark nebulosity in the area.
Yeah, there is. There's a lot.
There you go.
There's that central section right here. And then over here, Cygnus X1 is, see this orange and this white star here? Are those the ones maybe?
I think that's too far out.
Well, the orange star's on the right, and oh no, it's not. The orange star's on the left. I'm not sure it's too far out. Oh, we're looking at it. I'm not sure. Might be. Let's level with this. Okay. Okay.
It's about the same height in your image as those two brighter stars in that pattern on the left.
This dark nebula here, draw a line through it like this, and we're going to intersect those stars, but where are they? I think that might be these guys, but let me go back and check again. We're trying to find the location of Cygnus X1. I did it again. Used the wrong browser. Sorry, guys. Yeah, see that?
Red star on the left.
Yeah. I think that might be it. Well, wherever it went now, I just lost track of it.
Just above
right
your
here.
pointer.
Right here.
Yeah. Red star on the left. That could be.
Yep. That looks about right. Alright. Let's zoom out. We have 21 stacked here. This will be fun to process to see what I can pull out. I mean, keep in mind, it's literally at about 1/3 of the gain maximum that we could use with this camera, just under 1/3. And we have a moon on its way to waxing gibbous.
Yeah.
And
It
still
is
we're seeing
waxing
some
gibbous.
great, yeah, well, it is technically, yeah.
Well, this might be good for a darker the moon night.
Yeah, for sure. Let's go back down here. Let's see what this does for us. Oh, hang on a second. Okay. This right here, that's that little tiny spindly black nebula. Where that
Right there.
appears is let me show you guys. Right here, that little black nebula, okay, and this black nebula here, this dark nebula, that little tiny backwards C, right? And then straight across from this, roughly, we get these two stars, that lead to this faint shell, which is a shock front around Cygnus X1. Okay. Now we come back to our image, and okay, now we come across again, and these are those two stars, right, that leads to our Cygnus X1, which is right in here, and that little C is right here. You can see it right there.
I think that's too far out.
I don't think it is. I think we're just not seeing all the nebula.
That's a cool picture.
Yeah. And keep in mind that, you know, to be about the size of our sensor, we have to, you know, have our sensor fit in this frame. All right, hang on. We're waiting for Starlink. That's better. All right. There we go. Well, it's a bit of a messy night too, you know. It's not quite stable.
Yeah.
But not bad. Not bad for tonight, huh?
Sure.
Okay.
I think that's really cool. Mark, can you go to Spheriá for just a second?
Yeah, hang on. I'm going to pause this, and I'm going to save the Tulip Nebula. I put it up there. Okay. And then I'm going to save it exactly as seen. Okay. Now we'll come out of this guy and go back to our 1 second night vision shot. Now we'll go to Stellarium.
And where we're looking,
It's right there.
okay, so maybe about halfway between Satyr and Albireo.
Yeah, I would guess so.
Or,
You don't mean Saturn and Albireo.
well, it's down the long side of the cross,
Yeah, okay.
a little less than halfway.
All right, yeah, that's about right.
Okay, now I remember.
Yeah.
Or is that the tulip right there?
Right here?
Yeah.
Well,
Yes,
if it is,
okay. There's the stars and there's the dark bars. Yep, that's the tulip right there. So it's a little less than halfway done.
except that we have it right here, and it's showing our telescope in a very different location. So let me find out where my... Okay, yeah, that makes sense. It makes total sense because of the way I placed it in the field. We're good.
Okay.
Yeah. I just had to make sure. Yeah, because it's right here. Wow. Very cool. Alright, so now we're in the mode where we can actually move around again. There's got to be something else now that we can... Oh, come on, Mr. Cloud, stop it.
Wow.
We're getting a few clouds now. We didn't get any for the other exposures, which is really good. And our... Let's see our...
Love that picture.
It's nice. Let's do this. Yeah, there's gonna be some clouds zipping through here apparently. We're getting some light clouds now, guys. Obviously. As you can see. Ah.
A bummer. I thought it was going to be a clear night.
Well, clear to a weather person means no precipitation. And it's actually been mostly clear. You know what? Let me try to see if the all sky will pick up this time. That's another little issue I've got to work out, is why the all sky camera's not doing what it should be doing. Alright, we'll do one acquisition. And hopefully it'll do the acquisition.
Hey. And wow, look, look at all the clouds.
Okay.
Bummer.
Let's try one more. Well, we got lucky, guys, looking in between them. Got some alto cumulus clouds going there. Oh, mamma mia, that's a spicy meatball. Well, you know what? We got a good night. I can't say it was a bad night. It was actually a good night, wasn't it?
It was.
Yeah.
I
I'm
think so.
very pleased. Well, anyway, not bad. So what I'll do, guys, is obviously we're going to shut down because, well, clouds. So first thing I do, as always, is I shut down this the planetarium system. And now I can park the telescope. Sadly, I have to park the telescope. I don't want to park the telescope. And I go park it. And that means put it into that storage location where it faces away from any incoming weather of any kind, dust and so forth.
Izabela, we looked at a number of globular clusters early tonight. And then we looked at the lagoon. And then we went up to Cygnus.
Yeah. Yeah, definitely.
Glad we got to see the Tulip. Have to do that again sometime.
Yeah.
Dark of the moon.
Alright, well, that's there. So now what I'll do, I can go into this guy and get rid of that one. And what I'd like to do is come in here and do something I don't often show you. And let's see if I can do it. Okay, so there is the telescope parked and shut off. And now we'll shut the roof. And there we go. I mean, I don't know why, but to me, doing that from 2,500 miles away just feels so much fun. It's like I can move something. You'll notice over here also in this, you can see there's some spider webs that crop up. And you see a few, that's like a spider web right there that you're seeing. It comes back into view. So, you know, we have to routinely go out. We have to do maintenance like once a month in the building to get rid of spiders and other creatures. One thing we don't have inside the building is mice or rats. And they're very, very common out there. So our building is enclosed enough that we do not have that problem. Knock on wood. Yeah.
You know what's happening here in Colorado right now?
Womp rats?
The annual tarantula migration.
Oh, I love it. You getting pictures?
No, they're not happening here. They're down southeast of here. more like, it's south and southeastern Colorado. A town
Okay.
called La Junta, and between La Junta and a town called Trinidad down on the New Mexico border.
Okay.
It's not really a migration, but all the male tarantulas go out looking for girlfriends. And there's thousands of them crawling all over the place. Millions of them.
Wow.
So you think you got problems.
Tarantulas are harmless.
Yeah, I know.
I mean, they can give you a nasty bite. They can break your skin, like a bee sting, you know. Just twice. You have 2 fangs. Oh well. All right, guys. Well, you know what? It was great to see you. Thank you for coming out and hanging with us. We had a great time. Really enjoyed having you guys with us. So, next clear night, well, every other clear night, we'll probably do day after tomorrow if we do it. If it's clear, and I'm sure it will be. But anyway, I will talk to you later, and there's our music saying it's time to go. I hope you guys enjoy your night, and we will be back. Good night, everybody.
Good night, everybody. Take care.